In this video, we're still going to be talking about motion of connected particles. I'm going to call this case 2. Okay, this one will be quite different from the first one, but nothing really special about it. Okay, now let's say we're having a pulley. Okay, now this is going to be a frictionless pulley. Okay, a frictionless or a smooth pulley. Now there are two masses hanging over this pulley, of which we're going to have one here. Now I'll call this M1 and I'll call this M2. Okay, remember these two are hanging, okay, off a pulley, so there's going to be a weight, and that was what I'm going to call W1. I'm going to call this W2 rather and W1. Okay, tension is going to act here, and then tension is going to act here as well. Okay, here's the pulley. Now I asked to find the tension and the acceleration for a system like this again. Okay, so it's quite easy. All we have to do is bring out the equations and then solve for what we are asked to do. Okay, in this case, we are going to assume that W2 is greater than W1, so the body is going to move like this in this direction. Okay, M1 goes up and M2 goes down. So making the assumption W2 is greater than W1, okay, what are we going to get? Let's see what we're going to get. Now for this part first, we're going to have W2, okay, minus tension is equal to M2A. That's the mass times the acceleration. Remember, they have a common acceleration and a common tension as well. Okay, so from here, W2 is M2 times G. We're going to have M2G minus 2 equals, minus T rather, equals M2A. Now let's make T subjects of the formula. So when I take T to that side, I'll get M2G minus M2A equals T. Okay, and then from here, T equals M2G minus M2A. I'm going to call this equation 1, just like the previous one we did. Now, if you did not follow that one up, I'll advise you go back to watch that first video before coming back to this one, so you get more understanding on what we are doing here. Okay, and then for the other particle, which is M1, we're going to do the same thing, or rather, in this case, M1 is going up and M2 is coming down. Okay, so we're doing the same thing, but in the sense that in this case, we're going to be subtracting W1 from T. Why? Because T is assumed to be greater than W1 in this case, because T is pulling M1 upward, even when W1 is going down. So we're going to have T minus, okay, W1 equals M1A. Okay, now let's see what we're going to get here. This T minus M1G equals M1A. So from here, T equals M1A plus M1G. We're going to call this equation 2. Now let's equate equation 1 and equation 2 and then solve for the acceleration. So equating equation 1 and 2. Equation 1 is M2G minus M2A. So we have M2G minus M2A equals equation 2 is M1A plus M1G. Okay, that's what we're going to get. Now let's make A subject to the formula. So I'm taking M2A to the other side. That will give me M2G minus M1G equals M1A plus M2A. Okay, A looks common, so I'm going to bring out A. If I should bring out A from that side, I'll have M2G minus M1G equals A into brackets M1 plus M2. Okay, now making A the subject, that is by dividing both sides by M1 plus M2, we're going to have M2G minus M1G, okay, divided by, that's M2G minus M1G divided by M1 plus M2. So acceleration is equal to M2 minus M1 multiplied by G, because G is constant, so we can factorize it out. Okay, it is common on both sides, divided by M1 plus M2. Now here is the formula for calculating the acceleration for a body in a case like this. Okay, now we're having M1 be subtracted from M2 because M2 is greater than M1, which is same as W2 is greater than W1. That is the only reason. Now, assuming W1 is greater than W2, we will be having M1 minus M2 instead, okay? And that's what we're going to have. Now, the next thing we're going to take is the tension. We're going to solve for the tension. Now, to do that, I'll just substitute acceleration into this. Or I could choose to solve the simultaneous equation again, of which will actually take time, okay? So let's substitute into equation 1. So substitute A, okay, into equation 1, okay? Let's substitute into equation 1, that's what we're going to get. Now, what's equation 1? Equation 1 remains T equals M2G minus M2A, okay? That's what equation 1 is. And anyway, we see A, we're going to put this whole stuff, okay? So we're going to have T equals M2G minus M2, open bracket, what's A? That's M2 minus M1, okay, times G divided by M1 plus M2. Okay, we want to make T subject, so we're going to try and simplify this guy. Now let's open the bracket. We're going to get T equals M2G, okay, minus M2 times G gives you M2G into brackets M2 minus M1 divided by M1 plus M2. Now, here we can take LCM. By taking LCM, we should obtain T is equal to LCM of M1 and M1 plus M2 and 1 is simply M1 plus M2. Okay, 1 goes into this guy, that's M1 plus M2 times M2G. So we're going to get M2G into brackets M1 plus M2, okay, minus M2G into brackets M2 minus M1, okay. So now let's simplify further. Therefore, T becomes, now notice M2G and M2G are both common, so we can factorize them out. So we bring out M2G, open the bracket, so we should be left with M1 plus M2, okay, M1 plus M2. Now there's a negative sign here, so minus times M2 gives you minus M2 plus M1. Okay, so we have minus M2 plus M1 divided by M1 plus M2. So T then equals M2G, okay, into bracket. Now M2 minus M2, that's 0. Okay, now M1 times M1 plus M1, that's 2M1. So I have 2M1 divided by M1 plus M2. So T is equal to 2M1 M2G, okay, by expanding this bracket, divided by M1 plus M2, okay. Now here's the formula for calculating the tension for a case like this, okay. So I'm going to call this equation 1, and then I'm going to call this equation 2, okay. So to do this, what we're going to simply do is assume one way to be greater, and then bring out our equation to solve for the acceleration first or tension first, and then after getting the answer, substitute into any of the equations to find the tension, or if we solve for tension first, to substitute to find acceleration. So it is quite easy. And mind you, remember, these formulas are very, very much true, but only if we are having a smooth pulley, okay. In this case, the pulley is smooth. Now, how about a case where the pulley is not smooth and the pulley has a mass, okay? Hence, you have an angular acceleration.